Hi folks, in today's video we are going to be doing a recap of rates of reaction from National 5 Chemistry to help us understand the higher chemistry concept, so please keep watching. So let's go back to something called collision theory. So for a chemical reaction to occur, your particles must collide with each other. Now anything that increases the number of those collisions is likely to increase the reaction rate. Now there isn't a direct link between the two. Just because you have increased the number of collisions doesn't mean that you're going to increase the reaction rate. It's likely to happen. This slide basically explains all of rates of reaction at a National 5 level, so we'll start on the left hand side at the top. So as I say, I've got for a chemical reaction to occur, particles must collide with each other, and then anything that increases the number of collisions is likely to increase the reaction rate. So all of this can happen with 4 different ways. So you increase the concentration of your reactants, you can increase the surface area or decrease the particle size, so they're interchangeable. You can increase the temperature, and you can add a catalyst. Now you can measure the rate of reaction 2 ways. You can either measure by loss of mass of the reactant, and that is this little diagram here. Now what you can do is you can see that that is 220 grams, so that will get less as your reactant dissolves in the acid. Therefore you can measure a graph which would look like this going down the way. Okay, so with your reactant on this side and time across the bottom. You can also measure it by having a look at the formation of a product. That is the one at the bottom. So you can collect gas in 2 different ways. You can use a gas syringe, and you can also use it kind of over water, which is this one here with the trough of water. Now your graphs are going to look like the one at the bottom here, because you've got a formation so that you're starting with none and you're increasing it until you get a higher volume of it. Now your graphs from your rate experiments are usually used to identify information about the reactant. Now note as well, if you have a look here at the end, they start at the same point and they end at the same point. What that means is the same mass or volume of reactant has been used. If I have a look at this one, I start at the same, but I maybe finish at roughly half from the other one. What that means is I've got half the amount of the other one. So say for example, the pink and the green one was 1 gram of a metal. The blue one underneath could be 0.5 grams of your metal. And finally, you can use an equation here to calculate the rate of reaction. So the average rate can be defined in the change in quantity divided by the change in sign. Now that is that little delta sign. So usually the quantity could be something like centimetres cubed or grams, and then time at the bottom is seconds. So that usually gives us a unit of centimetres cubed per second, but not always. You need to be careful about what mass, what reactants and what products you've got as well. With higher chemistry, you've got something slightly different. You've got an extra thing to add on. So the particles must collide together, which is important. And they also must have sufficient energy to produce your product. And finally, they must have the correct orientation. Anything that increases the number and energy of collisions between the reactant particles will speed up the reaction. So you've got 3 new things to learn from higher as opposed to National 5. So that's a whistle-stop tour of National 5 rates of reaction. Feel free to go back and have a look at some of the National 5 past papers just to remind yourself of what you were asked, particularly with the calculations, before you move on and learn new concepts at higher chemistry.